Hi, so for today, we're going to talk about the variable separable differential equation. This is a part 3 of our video all about the variable separable. So the part 1, I have discussed it already. So please make sure to see it. And for part 2, we have a variable separable involving trigonometric functions. So for this video, we're going to do it for both. Okay, so let's get started. So for number 1, we have the x squared y prime equals e raised to y. So how do we solve this type of variable separable or differential equation? So first, we know that in this problem that y prime is equal to dy over dx. So it's best to rewrite it. So we have x squared y dy all over dx equals e raised to y. So we have also, if we manipulate this, we have x squared y dy equals e raised to y dx. Okay? So we will be grouping all of the y, okay, on the left side, terms of y because we have a dy here, and all of the terms on the right side, okay, for x. So because we have a dx. So what are we going to do? We have manipulating this, we have y dy all over e raised to y. Then we have dx all over x squared. So the next thing that we're going to do is to integrate this. But before we integrate this, we can rewrite this left side of our equation as the y multiplied by e raised to negative y dy equals integral of dx all over x squared. Okay? So that if we integrate this left side of our function, we are going to use integration by parts. So we know that we can let u equals y, and the derivative of u with respect to y would be dy. Of course, the dv would be the term that is left, e raised to negative y dy, integrating that, so we have negative e raised to negative y. Okay? So, rewriting this, so we have the formula of uv minus integral of v du. We know that when we use the integration by parts. So on the left side, we have uv, we have the value of uy multiplied by v, which is negative e raised to negative y, okay, minus the integral of v du. The v is negative e raised to negative y, and our du equals dy, and that is equivalent to the integral of this. So the integral of this, we know this by power formula. We have x raised to negative 2 dx. Okay, later on, we simplify that. So, y times this would be negative y e raised to negative y. And I can factor out the negative outside of the integral sign so that this becomes positive. Because of negative times negative, we have e raised to negative y. And still dy. Get the integral of this. Okay, so this would be x raised to negative 1 all over negative 1. And we add plus c here on the right side for equation. Okay, so what will happen is that we have, okay, now negative y e raised to negative y. So integral of this would be negative e raised to negative y equals, if we simplify, okay, and we know that this would be negative 1 all over x, okay, plus c, okay. So I can factor out the negative sign here, okay, on our left side. So we have negative e raised to negative y. That would be y, okay, plus 1, okay, equals negative 1 over x plus c. If I'm going to multiply it both sides by negative 1 so that we can eliminate the negative 1, so we have e raised to negative y of y plus 1 equals 1 over x. Doesn't matter, this plus c won't be affected. That is still a constant, plus or minus. That is still plus c. Okay? And if we simplify this, we have y plus 1 all over e raised to y by loss of exponent. And we have 1 over x plus c. If we multiply both sides by e raised to y, x. Okay? So this would be our final answer. X, quantity y plus 1 equals, we have 1 plus, okay, cx, okay, multiplied by e raised to negative or e raised to y. Okay. So this will be our answer for problem number 1. We did an integration by parts as our solution for our integral. Okay. So for number 2, let's try again another problem. For number 2, we have quantity e raised to 2x plus 4 y prime equals y. So the very first step again we're going to do is to rearrange this. Okay, isolate dy and dx. So we have e raised to 2x plus 4. We have dy here and we have y dx on the other side. So grouping in terms of y dy of all terms in y in dy and all terms of x in dx. So we have dy all over y equals dx all over e raised to 2x plus 4. Okay? So, and then we integrate. Okay, we know that dy over y is ln of y. Okay? That is as simple as that. So, but for this integral, you might be thinking, how are we going to solve this integral? Okay? So, we can solve this integral by simply, this can be a tricky one. Okay, you might be tempted that it is an arctan, but it's not, because if we choose u as e raised to x, okay, that is 2, the derivative of that is 2e raised to 2x. So, we don't have e term here in our numerator. Okay, so we cannot use u substitution. So, we can simply rewrite this as, by loss of exponent, that is equivalent to 1 over e raised to negative 2x plus 4. Okay? And we try to simplify that. Okay? So what will happen? We add it. So dx all over, we multiply this by this. Okay? This would become 1 plus the multiplication of this 4e raised to negative 2x all over the same denominator, e raised to negative 2x. And upon simplifying this, okay, we know that this will become our numerator in the dx. Okay? So how did we do that? So we have dx, okay? We get the reciprocal of this, okay? And we will change this division into multiplication. So we have e raised to negative 2x all over 1 plus 4e raised to negative 2x. Okay, so what will happen is that we have e raised to negative 2x dx all over 1 plus 4e raised to negative 2x. And by this, we can let u equals 1 plus 4e raised to negative 2x. The derivative of u would be 0 minus, because of the negative sign here, if we get the different derivative of this would become 8e raised to negative 2x dx. Okay? So let me just rewrite. This would be negative 8e raised to negative 2x dx. This is 0 because the derivative constant is 0. So we can get the e raised to negative 2x dx. So du all over negative 8 equals e raised to negative 2x dx, because this term is available, okay, in the numerator. So we can now substitute. Okay? So we have ln of y. ln of y equals, substitute the du and u. So we have integral. We can now substitute, okay, this would be du all over negative 8 all over u. We know that we can factor out negative 1 over 8 and get the integral of du all over u, of which we know the integral of that very well. So this would be negative 1/8 ln of u plus c, where u, we will back substitute it. Value would be 1 plus 4e raised to negative 2x. So we have ln of y, Okay, negative 1/8 of ln of 1 plus 4e raised to negative 2x plus c. Okay? And by properties, and we can multiply whole side of equation by negative 8. So this becomes negative 8 ln of y equals ln of 1 plus 4e raised to negative 2x plus c. By properties of ln, this negative 8 can be the exponent of whatever inside function inside the natural logarithm. So we have ln 1, okay, ln of 1 plus 4e raised to negative 2x plus c. Okay, and then if we exponentialize or raise it to e, okay, what will happen is this. Since this is an addition, we can also change it into e raised to c, of which e raised to c would be c constant. So we have y raised to negative 8, and then we have 1 plus 4e raised to negative 2x, and then we have c here. Okay? And then if we bring down 1 over y raised to 8, that would be the solution, okay, multiplied by c. Okay? So if I multiply both sides, okay, by y raised to 8 and divide it by c so that I can eliminate c here. So what will happen is 1 over c, okay, and then we have 1 plus 4e raised to negative 2x y raised to 8, and 1 over c will still be equal to c. So we have y raised to 8, 1 plus 4e raised to negative 2x. So this would be our answer. Okay, for number 2. Or the answer can also be cy raised to 8. So in other words, if we do this, okay, without dividing it by c, we will be having 1 equals 1 plus 4e raised to negative 2x c multiplied by y raised to 8. That could also be the answer. Okay. So I just followed the book, simplified version. Okay. So whichever is the answer. So for number 3, y prime of equals y secant of x. So again, we have dy all over dx, and we have y secant of x. So we have dy all over y, and we have secant of x dx. So we have already separated. Okay. So it's time for integration. So we have ln of y equals the integral of secant of x would be ln of secant of x plus tangent of x plus c. Okay, and of course, if we raise this both sides, okay, by e, so we have e raised to ln of y, e raised to ln of secant x plus tangent x, okay, and this is plus c. So let me just rewrite again. So that by properties of ln, okay, we have e raised to ln secant x plus tangent of x, okay, multiplied by e raised to c. Okay. So that this would cancel. Okay, e raised to c would be equal to c. So yeah, y equals, okay, secant of x plus tangent of x multiplied by c. Okay. So that would be our answer for number 3. Okay, for number 4, let's try another one. So for number 4, we have x to y cubed dx plus y plus 1, okay, multiplied by e raised to negative x dy equals 0. Okay? So first, okay, we can rewrite this, separate x dx and y in terms of dy. So we have x dx all over e raised to negative x plus we have y plus 1 dy all over y cubed equals 0. Okay? What I would like to do is to transpose this on the right side. Okay? So what will happen? We have y plus 1 dy all over y cubed equals negative x dx all over e raised to negative x. So again, let me just rewrite this. Y plus 1 dy all over y cubed. By properties of exponent, this is equivalent to negative x e raised to x. We have dx. I have bring this up in the numerator, but I'm going to make this positive. Okay? Negate this, so negative of negative would be positive x. Okay? And then, of course, we have to integrate. Okay? We have to integrate this. Okay? So, what will I do here? Okay, is simply separate them, y dy over y cubed plus integral of dy all over y cubed. I can factor out the negative sign outside of the integral sign here. That's the negative one. And we see that this is again integration by parts. So we have to let u, of course, x, derivative of u with respect to x will be dx. Our dv would be e raised to x dx. Our v would be e raised to x. Okay? So, as you can see, this would cancel. This would become dy all over y squared. Okay? Plus the integral of y raised to negative 3 dy. Okay? And equals integral of x e raised to x dx. So, we can rewrite this as y raised to negative 2 dy plus y raised to negative 3 dy and of course negative integral of x e raised to x dx. So, shall we continue on this side? So, if we integrate y raised to negative 2, that would become y raised to negative 1 all over 1. Okay? Then we have, if we integrate y raised to negative 3, that would be y raised to negative 2 all over 2. Okay? That would be the, I would like to add the plus c here on the left side. So, integrate this. So, we have negative, okay, that's the negative outside of the integral sign. uv minus integral of v du. u times v, that's x e raised to x minus the integral of v e raised to x du is dx. Okay, so simplify this. This would be negative 1 over y. And this would be negative 1 over 2y squared on the denominator. Negative 2y squared plus we have c. And then we simplify this. This would be x e raised to x. Integral of e raised to x would be e raised to x simply. Okay. And then what would I like to do since we have both negative here, I would like to multiply the whole equation by negative 1. Okay, multiply the equation by the negative 1. So we have 1 all over y plus 1 all over 2y squared and still plus c. And then we have x e raised to x minus e raised to x. Okay? So to furthermore simplify, we have 1 over y plus 1 over 2y squared plus c, and then we have e raised to x, x minus 1. And this would be our answer for the problem number 4. This is our solution. Okay, I think for our last problem, since I already have a video about this, the integral of 1 plus ln x dx plus the integral, not the integral, okay? That's the differential equation. Okay, so we have 1 plus ln y dy equals 0. Okay? So, this is already arranged. So, we can simply get the integral. Okay? So, integral. Okay? So, what will happen? By properties of integral, I can separate this plus the integral of ln of x dx plus the integral of dy plus the integral of ln of y dy equals the integral of 0. Integral of x is x. And we can use integration by parts here. Let me just rewrite this so that we have space. Integral by parts. So we have to let u equals ln of x. The du is 1 over x dx. Of course, our dv would be the dx. Okay? And v equals x for this. Same rule for this. Integral by parts. Integration by parts. So you have to let u equals ln of y. We have du 1 all over y dy. Okay? So we have dv equals dy. Integrate b equals y. Okay? So we perform uv minus integral of v du. U times v, that's x ln of x. Okay? Minus the integral of v, which is x. Our du is 1 all over x dx. Okay? So this is our v. Okay, this is our du. So as you can see, this would cancel. Then plus the integral of dy would be y plus, okay, uv minus v du, that's y ln y uv minus the integral of v du, which is y. Okay, our du would be 1 all over y dy. And as you can see, this would cancel also. Okay, equals c. Okay, so we simplify x plus x ln of x minus, okay, x plus the integral of dx now will be x minus, because we have minus from the formula of integration by parts, plus y ln of y minus, okay, the integral of dy, which is y equals c. So you can see x minus x would cancel. So we have plus y minus y would cancel. So we are left with x ln of x plus y ln of y equals C. And this should be our answer for this problem. Okay, and I hope you learned something for today's video. Thank you so much again. This is Variable Separable Part 3. Okay, so wait for my videos all about strength of materials, statics, okay, engineering economy, and more mathematic videos and more topics all about differential equations. So thank you so much for tuning in. I hope you learned something for today. Again, this is Engineer Abat, and God bless.